force between two charged pieces of tape. The purpose of the experiment was to estimate the amount of charge that would in each tape. We used two methods, one experimental method and then a computer modeling. I created two codes, one with a single point at the tape at the origin, and then two with a line of charges at different locations to represent them accurately to the real world. My results show that the line charge model required a larger charge to raise the tape past gravitational force, and the single point charge didn't need as much, but it was less accurate. So some physics concepts that I used was Coulomb's law to calculate the force between the tape. There's the equation right there with the K is the constant, Q is the charge, and D is the distance, and then just the gravitational force, which is just mass times gravity. The system and the surroundings. The system I said was the upper floating tape. The surroundings was the lower tape for the electrical charge, and then the Earth for the gravitational force. The measurements I got from this lab, the mass was 0.0002 kilograms, the length of the tape, 20 centimeters. The distance after completing the lab between the two tapes I found to be 0.03. So this is the lab. This is a photo of me trying to get the charge with my hand from the tape. During this lab, the first thing I did was attach the tape to the desk, rip it off, try to get the charge. Then I would test the sign of the charge by observing how it interacted with other objects. I'd use other tapes. I'd use my hand and then a plastic pen. Next, I would take two similarly charged U-shaped tapes and try to use the electrostatic repulsion force to lift the other one past the gravitational force. The mass of the tape, the separation and distance were all measured by balancing the electrical force and the gravitational force and applying Coulomb's law with assumptions and stuff. I was able to find the electrical force value that was able to get the tape lifted past the other one. And finally, the estimated charge was used to calculate the number of excess electrons on the tape and compare this number to the approximate number of atoms on the tape surface. Two questions I pulled from the lab that I thought were, most important ones were my original expectation. I thought when taking two U-tapes, they would repel each other. And another one was a free body diagram. I have it here, tape B. You have the force from tape A on top and the gravitational force pulling it down. Some measured forces. The gravitational force is just mg, so the mass of the tape times gravitational constant. And then the electrical force is the same once the tape is floating, so it's the same number. And the charge, I use Coulomb's law, solve for Q. I end up getting 1.4 times 10 to the negative 8 for my Q value, with a single point. It's just on paper. So what the first model was it takes, or finds a charge from a single point that's looking at the origin of the tape. So it's just one force, from the origin, repelling each other. This is my function I use, just Coulomb's law, calculating the electrical force. I end up getting the same number I got from my written model, so that's pretty expected. The second model, this one where each tape was measured as a line of equally spaced point charges. The total charge was distributed uniformly across the tape's length. The electrical force between every charge element of the bottom tape and every charge of the top element was calculated and summed up. So I took a snippet of the code. This code basically just is a summation of the Coulomb's law of each particle and combined to a single force. So you can see my model. I have one force going up and then one force going down. It's just a summation of all the forces combined. But you can kind of see in this picture that my Q value was not enough to lift the tape past the gravitational force. So what I had to do was solve for a new Q value. How I did this, taking the square root of the gravitational force over the electrical force, got this number, multiplied it by my original Q value, got my new Q value, which is 2.9 times 10 to the negative 8. The first what if question was, what if the electrons were positive and the protons were negative? For this question, I said that the results remain the same. Like charge will still repel, opposite charge will still attract. Coulomb's law doesn't really care, what's assigned to what. It just looks at the charges, looks at the negative signs and the positive signs. So, whether or not this, where the negative signs were, switched for positive and negative, the result I think would still be the same, just based off the math. The next question is the why question. Why are the point charges and the line charges values for Q different, and which is more accurate? So, the reason different is the point charge model assumes that all the charges of each tape is concentrated at a single point, and this basically simplifies the calculation, but it doesn't really accurately represent what happens in the real world, and it gives us a larger value for Q. The line charge model is more realistic because it distributes the total charge across the entire length of the tape. In this model, different portions of the tape are at different distances from one another. Since the electrical force decreases with distance according to Coulomb's law, many of the charge interactions are weaker, then they have a smaller value. So as a result, the line charge model predicts a smaller electrical force or smaller Q value for the same total charge, and the single point model gives us a larger value for Q. So then the conclusion, basically in this lab, I was able to use Coulomb's law, gravitational force to calculate a Q value that I would need to lift the tape using electrical force, past gravitational force. I used the computational models. I used the experimental methodology method to use different ways to solve for this value. Some errors that might have been in my lab were maybe the humidity of my room or the charges weren't exactly the same on the tapes. But in my lab, I wasn't able to get the tape to lift all the way up, but I mean, kind of slightly I got it. But I was able to use the computer models to compare, like a single point to a more accurate line of points to show how charges differ with how you calculate this Coulomb's law.